You know, not everybody can go and become
Okay.
VPs and whatnot.
True. We're founders.
Wait, are you a founder now? Oh yeah, obviously.
So welcome to if people could not mute the Toronto Perl Mongers account, that's where the audio is coming from. Just click on Dave to focus the video. All right. So one of my favorite things is actually just little tips, tricks, tools, utilities, client or command line tools, some little program that does a nifty thing. Sometimes they're little things, but they're some of my favorite things. So if you're on a Mac, you often use iTerm 2. Strangely, it's now on version 3. And there are some little things in iTerm that are very handy for a developer. For one thing, if you hit on a Mac command /, it actually tells you where your cursor is. It blanks out the entire screen except that cute little thing, and it's very handy if you have a hell of a lot of terminals open or a TMUX session or something. Command K is something I learned from Greg over here. That will wipe out the screen, much like a clear would, except it also wipes out all of the scroll back. So if you're about to do something and you want to be able to search through it, Command K, easy peasy. Another thing you have in iTerm now is instead of tabs along the top, you can have tabs along the side, which is great because I also tend to have a fuck ton of tabs open. And even the search has gotten better. You can do regular expressions in the search of your scroll back, which is really quite handy. I also like the fact that iTerm is capable of doing some image stuff. If you get some of the little utilities like ImageLS and ImageCat, ImageLS will give you a nice little thumbnail of your images as you go, and ImageCat will actually show you the image in your terminal. Highlight is a nice little command line tool you can get through Mac or Homebrew for Mac. You can probably get this pretty easily on Linux. Anything on Homebrew is pretty much there for Linux. It's a great little tool for code highlighting. You can do it just to the terminal with ANSI. You can generate HTML, LaTeX, and all kinds of other formats. So if you have a big code base, you can very quickly generate an HTML, syntax highlighted version of your code with the highlight tool. So in this case, I was just outputting some Perl in ANSI. It'll auto-detect it if you pass it a file, but it also takes standard in, at which point you can specify the type. And it just quickly gives you a nice little way to view code just in a terminal. PB copy, PB paste, which is another thing I learned from Greg over there. I freaking love this tool. So PB copy and PB paste on a Mac is basically taking and putting to the clipboard from any other application. So for example, here I have, I took a copy of some JSON that was in a single line in my editor. I PB paste it, I pipe it through to JSON-XS to prettify it, and then I paste it back out to PB copy. So it'll shove it back into the clipboard and I can paste it. You can even go further and you can highlight it. So I did this as well with the highlight from the previous thing. PB paste the code, run it through the JSON prettifier, and highlight it. Really handy little tool. HTOP. This is just a really cool little thing that I can't believe I didn't know about, and apparently everyone else does. A replacement for top, it's much more visual. You can scroll left and right, up and down, so you can see everything. You can view a process tree. It's showing you, each individual core on your machine. It's just a nice little quick way to kind of have a little more power than top, or at least a little better visual representation than top gives you on the machine. Similarly, PS tree, which is a nice little thing that'll generate a process tree for all your child processes. You can give it, you can do everything, which is a horrible word, blur. But if you give it, a PID, you can get a nice little tree there. You can filter it and do all kinds of different things with it. We kind of keep shifting from theme to theme. Now we're just onto tree, which generates nice little directory indexes in ASCII, which you can copy and paste into documentation when you need to generate a nice little tree instead of manually typing it out. And remember this GIF? This was made using Record It, which is a nice little Mac app. I think there's also a Windows version. Yeah. So it lets you take video that you can output as a GIF. You can do up to 5 minutes. Really handy. You give it a window the size of what you want to do, and you have a GIF. And that is that. Thank you very much. Okay, and now I'm going to stop sharing my screen and call Ted up.
Cool. Thank you for telling me why I would use HTOP, because everyone just tells me because it's better, which doesn't help.
So next is Ted. He's one of our in-house recruiters here. And basically, I didn't get Ted to prepare a talk or anything. He's just going to answer questions. And my favorite question is, how do I make myself invisible to agency recruiters and visible to people like you who actually work for companies?
Yeah, so that's exactly right. So this is like, I will not try to recruit you here, I swear to God. Just ask me any questions you want to know about recruiters, how to become invisible, how to become more visible, whatever you want to know about how these guys work. I worked for the enemy for 3.5 years and I was young and didn't have a lot of integrity yet, and was taught by people who didn't have a lot of integrity, and put a lot of people at Microsoft, which is not necessarily the greatest place in the world to work. And a couple other companies as well that were good. And then I got to work for Salesforce for a long time, and I got a lot of experience working for a good employer, and then I got to do that thing. And now I work here and I hire people for Influitive. So we won't try to hire you for Influitive tonight, but if you have weird questions or if you want to learn stuff about how people like me think, I will be totally honest with you and tell you how to avoid us or get in contact with us or anything you want to know about how these guys think. I'll tell you how they think and why they do it. So your first one was, pardon me, what was it?
How do I make myself invisible to agency recruiters, but visible to you?
Okay, so you have a preference for in-house recruiters. You'd like to be contacted by those people.
Yes.
I think like the easiest way to become invisible just in general is if you do have a LinkedIn profile and that's a normal part of your life. Most recruiters will use a special tool that LinkedIn has developed called LinkedIn Recruiter, good name, and they search by geography first. So if you are a person who lives in Toronto and you are a developer, then they may do a search that says Toronto developers. The easiest way to not ever get found again is to not be in Toronto anymore. Just make yourself from Canada and you will not appear in their search any longer. So if you do that, you'll become completely invisible to anyone who's trying to search for you on LinkedIn without actually knowing your name. The unfortunate part of that is that sometimes they'll look at specific companies. It's kind of the second way you can do a string. So you can look at a search by geographic location. The second way you can do it is say, get me a list of all the developers at Influitive. That's more difficult to avoid. So you could do is you could show that you were at Influitive in the past, right? You could say that you're not currently at Influitive. And that's one way to kind of do it. If you're not looking for a job, you don't really care if people know that you're at Influitive still, you could do that and update it every quarter, just bump up the date. How do you become visible to recruiters that you want to know from? That's more difficult. You kind of have to target the people that you do want to speak to and let them know that you're available, which is unfortunately more of a sales-ish kind of thing, which none of us like doing. So I would say if you really want to be noticed by, let's say you're hell-bent on getting a job at Influitive one day, then you would just reach out to the guy like me and say, hey, when you have a spot, I want to talk to you. It doesn't have to be today, it doesn't have to be in 6 months. Or you really want to go and work at, what's another cool Toronto company? You want to go work at Wealthsimple, right? It's a cool company. find the person in Well Simple, send a message and say, when you got a spot, I want to talk. I think that's probably the easiest way to do that. Anybody else want to know a secret of how people like me think?
Actually, I do have a question.
Yeah.
One of the co-organizers of this group, actually, who is not here or online at the moment, unfortunately.
Yeah.
His solution to the agency recruiter problem was to post his LinkedIn picture of him in a multicolored clown hat. Or hair, sorry. Would that work?
No.
Ah, damn.
So when I was at my last company, the cultural mandate was really important, and we would hire people from different industries a lot. And we would actually look for people like that. That would be a better fit for what we were looking for. But you're kind of right that sometimes some of those agency guys are a little stale, and they want to find someone who is particularly stale for their client that they view as stale. But they don't really know. They're not really great recruiters typically. Like they don't want what's best for you or what's best for their client, right? They're motivated by the marriage, right? Whereas like in my job now, I have the luxury of actually enjoying where I want to work, and we all have stock options, so we want the company to succeed. So if the person comes in and lasts 3 months, then we just wasted a bunch of money. That's bad for Dave and I. So clown hair actually could be really good, right? Clown hair's kind of funny. Some of the most brilliant people I know are a little crazy.
So if you were working as a recruiter, what would be the reasons that you would ever like drop a company? Like you're recruiting for them, you hire a few people for them, and then you decide that you don't want to deal with them anymore.
So one of the agency recruiters might do that.
Mm-hmm.
Well, they typically wouldn't. They try their best to hold on to them. Sometimes people don't pay their bills. The other thing that happens is the way their business works is they get a fee for placing you, and it's usually a percentage of your salary. So to some extent, the industry has been cannibalized over the course of the last 10 or 15 years. They used to make as much as 30% of your base salary. So you get paid $100K for a round number. They would get a check written for $30K as soon as you get hired at the spot. If the company said, no, we're only going to pay you 25%, or only 20%, or only 15%, then they may choose to dump the client. But over time, the percentage has gotten lower and lower to the point now where I think the normal fee is around 15 to 20%. I've heard as low as 13. Where you've really got to watch out, if you're a kind of person who's a contractor, that's where you as the worker can really get screwed. I've seen people who are being paid something along the lines of $60 an hour that the agency is charging $170 per hour for. And the end client, a lot of the time, may be none the wiser. And that's around the .com 2000, 2001. That's why the industry got so big, is because you would have 30 people deployed like that, and you couldn't stuff the suitcases filled with the money that those guys are making every week. And now there's so many agencies out there, and this still happens. So if you are a contractor, do your best to figure out what the bill rate is, as well as the pay rate. And if it's not fair, then you need to know that difference. And it also matters if you choose to go permanent with them, if that's your goal, because then you have the ability to get quite a bit more money when you actually go permanent.
How do you deal with the places that are really trying to recruit for a country club rather than actually get code?
If you're the agency recruiter, it doesn't really matter what happens to the human on the other side. That's their attitude. Just sort of sickening. Speaking in terms of...
I'm thinking more in terms of the, quote, cultural fit, unquote.
Can you elaborate on your point? So...
I'll give you an example. Actually, this has been going on for a long time. Back around 1970, I was working for a company, and the manager was trying to define the ideal, or define minimum qualifications for a programmer. And he picked a school leaving exam. I pointed out a path of somebody who might have left school in the Depression, and learned signals in the Navy, and worked his way up through machinery, which would have put him at about 55 at the time. And the manager's put down for that was he wouldn't fit in with the other programmers.
Okay.
That's what and that organization was recruiting for a country club, which is why they went bankrupt shortly afterwards.
Okay, so how do I feel about that, or what would I do about it?
What would you do about it?
It's sort of his loss. That the attitude, the ageist attitude of the tech industry is, people know about that. I think we're pretty famed for it. What I would say to that is that culture is actually not to do with age, I don't think. I think companies that are more astute when it comes to culture will say it's about values. So for example, if everyone in the company is predisposed to take a lot of ownership over their work, maybe because they own stock options or because that's something that we look for in our people, that they're willing to actually put their blood, sweat, and tears into their work, then that should be a cultural value that we all espouse. And when you get on the phone with someone and they say, look, I need to be making $100 an hour, otherwise I don't even want to talk to you guys, then you pretty much know that person's not going to be a culture fit. So I would say that the person, that personification of a hiring manager that you just described, that's probably not a very good manager. Or it's a company that doesn't have a very sophisticated understanding of culture. Right? And maybe it is best to avoid that. It's unfortunate that happens. Same thing happens to women and minorities, though. And then many other ways that you can segment people out. I've worked for a company before that will only hire people that have done sports. That's very important. All of their people in this particular category of the group, they have to all play sports together. And that's what's important to them. And to your point, that's a great way to go into business. So it's kind of unfortunate for them. I don't know if I accept that.
Having been told I'm too old for the industry, I can understand why.
Yeah. You know what? 2 days ago, actually yesterday, I was speaking to someone. I had an hour-long conversation with someone who's in the same, she's not in recruiting, but in like HR and talent stuff. And this person felt that she, being a woman and a mother and being 40 years old, didn't fit into this tech scene culture. And we talked about it for a long time. We decided in the end that, you know, in the company that I was describing before, the sports company, so I worked at that company, and I'm a gay man, and they don't really hire gay men at that company, but I succeeded in the organization. And the reason that I did it was a lot about my personal brand I set forth. And although that I don't fit into your stereotypical view of what you hire at the company, I'm actually just as good as the other folks. And I very carefully handled my brand so that I could still be competitive, which is kind of the sports thing, still want to win on a team, which was the sports thing, right? And so I identified really well with the culture, even though I didn't play sports and I came from this other background. And for her, it was the same thing. Just because you're a mom doesn't mean you can't be committed to work. Just because you're a woman doesn't mean that you can't be amazing in the tech industry. So that is the unfortunate stereotype, but her personal brand needs to be the things that are going to make her successful at the company. And I don't think being a woman or being a mother should hold you back from that. That's my thought. That's a opinion, but that's how I feel. 5 minutes? Anything else?
I have a question.
Oh, we got one on the line.
Yes. Is there any way to get feedback on an interview after which you were turned down for a job?
Yeah, totally. The first and most painful way you can do that is Glassdoor. I think the world is more transparent now. You get data a lot faster. And if you feel that it didn't go well because that person didn't do a good job, that's a great place to put that feedback, because you better believe that their management's going to be looking at that. Unless it's a very, very small company, but anything that's bigger than 100, they're going to be looking at that very quite carefully. The other way that you can do it is just send a note to their sales team. So everyone will have an email address that you can reach the company and say, look, I felt that this happened, this happened, this happened. You'd be surprised how those sales emails will find their way to the right person inside the company. Right? So that's what I would say. And if it's the vice versa, if you are actually quite happy with something and you want to give positive feedback, which, hey, like you put out only negative stuff out into the world, it's probably going to come back at you. So if you have something positive to say, I'd say both of those will work as well. Okay, let's make this the last one because I don't want to.
How would you hire for a very specific skill set like Perl? So like more than just, oh, I'm going to search for Perl on LinkedIn. Would you do anything else?
Well, the most effective way of hiring today in Toronto is having a strong employer brand and having a lot of inbound. Yeah. So it starts with a long-term perspective, right? I think that there's a lot less cold calling now, believe it or not. There's a lot less cold calling and outreach now today than there was before. That may be a little bit untrue maybe of developers now that I think about it, but the long and the short is the best way to attract good people is to have a great place to work. So that's where you begin. Layering on top of that, if that's not working, yeah, you're going to have to start reaching out to people, and you find them through LinkedIn typically. The other way that you can find them though is through referrals. Craig is a really cool guy. I like him, and he knows cool people that are also smart and maybe good. And he's kind of useless to me because he's been here for a long time at this point. But
I'm pretty useless to a lot of people.
Well, that's the thing. But the people that you know that are good, that think working at your company is a good thing, they'll be willing to support you. And so asking for referrals or asking nicely, do you know anybody that can fill this spot, can be really helpful. Dave is an advocate of Influitive and has referred a lot of people to our company, right? And some of them have stuck, and it's been a great thing. And others, it wasn't quite a fit for them or for us or whatever, and that's okay too. But yeah, I would say it all starts with employer branded inbound marketing. Yeah, okay, maybe you have to do some cold calls, but if you can get a referral, that's probably a pretty strong way to get to. Well, hopefully you guys found that either interesting or helpful in some way.
I did actually.
Okay. I'm gonna go drink beer with his friends. See you guys. Have a great night.
All right, who wants to go next? Doug.
All right.
I totally saw your hand go up, buddy. How are we doing presentations, by the way? Like, are we emailing you them or something?
Do you have them online?
Sort of?
You can email it to me.
Where would I send that?
David.Doyle@Influid.
Oh, yeah.
I've
Okay.
worked with you. Did or up?
Start with the update, yeah.
All right. Hold on one sec. Let me refocus the broadcast. There we go.
Oh, did I make it bigger?
Yeah, final.
Don't worry about it. Yeah, so update immutable. It's I started using React a little while ago, and I think it's really cool. I don't know if anyone here else uses React, or is it? Yeah. But they have this one utility called Update, and there's the website for it there. It's not like a really core part of it. I think they just kind of made it because it's a little bit useful for them, but it's used a lot internally in React, and I guess they exposed it. And yeah, the idea behind it is that you can have these small little data structures called updates, and you can apply them to usually bigger data structures and make some modification, makes a new data structure, right? But the key is that it doesn't actually change the original one, right? It effectively, like, you can think about it like cloning, like a deep clone, and then applying modification. So the old copy is still there, it's still fine, right? However, your new copy has the modification. And you can see there's this little language here, like the $set, that says to set it to 2, right? Set the B element to 2. And then you can see in the output there, you have the new one next now has the 2 keys, A and B, but orig is still the same as it was before. But one of the keys is that it's not actually doing a deep clone. It shares as much as possible of the data structures. And that's really key in the way that React works, because React actually uses these data structures. When it determines when it finds that one subpart of it has changed, it knows to re-render the component that's mapped to that, right? So with Update, it's really cool because you can have a big, deep, nested data structure, make a tiny little change somewhere deep in there, and the only component that's actually updated is the one that's really deep down inside there, and none of the other components are referenced or are updated, right? Like in this example, you can see I've got an array, right, with one element, 3, 2, 1, and that's not touched, that's not changed. So in orig and next, that A key is still the same array, right? So if you have a should component update method, it'll just do a simple shallow comparison, see if they're the same, and therefore any components that are mapped to that array don't need to be updated. This is the little summary of their little language, right? So there's set, merge, push, unshift, splice. A lot of us have Perl analogs because they're copying JavaScript sort of functionality, which in turn was copied from Perl, most of it, right? And yeah, it's I won't get into the details there, but you can do all kinds of stuff. So one of the really awesome implications of these sort of serialized updates, like an update that you can encode into something like JSON and send around, is that you can actually, with React's help and some server-side support, you can maintain a shared data structure on both the client and the server and apply updates either on the client or on the server and send them bidirectionally and have them reapplied, right? So it's really, you can almost think about it on the server side as doing a direct to DOM update with minimal overhead, right? You just have to figure out what you want to update, serialize the update, send it across to the browser or vice versa, and it's applied. And on the React side, the very minimal amount of components that are required to perform that update are applied. One of the details, of course, is that you need to have this update implemented on the server side, which isn't a problem if you're writing your server side in Node.js, but who wants to do that, right? So update immutable. It's a new Perl module I uploaded a while ago. It implements almost all of the React update, except for there's this one called apply, which takes a function. I didn't implement apply because it's not serializable, right? Functions, you can't serialize functions, send it across the wire. So it wasn't really much use for me. Another advantage is a simple recursive implementation. It's not tied to React at all. Sorry, I implemented 2 versions, the Perl version and the JavaScript version, another JavaScript version. But yeah, my JavaScript version doesn't have React dependency. Another thing is that, yeah, there's this unset feature, which I use all the time. It's very important to delete a key from a hash table, which React's refusing to merge for some pretty dubious reasons for some reason. And then there's also a little bug in unshift. I mean, arguable bug. I fixed it to make it work like Perl does. And finally, auto vivification. The JavaScript implementation, if you try to set, okay, let me just go to the next slide. Auto vivification is awesome. The JavaScript version doesn't do auto vivification. So in other words, if you try to update like a really large like a really deeply nested hash key, if any of those hash keys along that path don't exist, it'll throw an exception, right? Perl, of course, as you know, will automatically auto vivify and create those keys for you, create the hashes for you, which is extremely useful. And one of the main advantages of it is that when you create a component in React, you have to create all of the potential state variables, even if they're empty arrays, empty objects, all this stuff. You have to create them and you have to maintain those whenever you change what the states are. I much prefer to just have it like, the client not even have to have that information on it. The server just auto vivifies and creates a big chain of states for it. So I added that. Right. So yeah, as I said, I made a Perl version and a JavaScript version and the JavaScript version fixes all the issues I found with the React and it's standalone. And the Perl version is its companion module. They implement the exact same thing. So yeah, you can get it on cpan, update immutable. And then yeah, also I've uploaded the JavaScript version to NPM. Yeah. Thank you. Any questions on that? Or?
Is it using the actual JavaScript structures, or is it doing something like immutable JS and actually implementing or re-implementing them with tries?
It's doing it itself with the JavaScript structures.
Ah,
yeah.
Cool.
So it'll do like a shallow clone of an array if it needs to modify it. Yeah. Immutable.js is really cool actually, and I think React is moving towards that model a lot. I haven't really been able to figure out how to serialize updates and send them across the browser yet, though. But I'll have to look into that. It might be possible to have like some mini sub-language that can harness immutable.js too. Yeah, immutable.js is actually a lot more efficient too, I think, because you can have like arrays that are partially shared. Update immutable, it can't really do that, right? Like the array itself needs to be shallow copied, even if it's like 1,000 elements long. You need to make a shallow copy.
I think Jim is suggesting a blog.perl.org.
Oh, yeah.
Post is in order.
Awesome. Yeah, good idea. Good idea. So my next talk, sorry I'm doing two, is about PID control, PID control. Does anyone know what the heck this thing is other than Aviana? Okay, it's I'll get to it, but it's nothing to do with process IDs or anything like that.
Oh, good.
It's about control theory. Okay, so basically, control theory. Okay, this image is an example of a single input, single output system. So it's a very contained system. It does exactly what it says. It has one input, which is, let's say it's a temperature input, right? It's you have a thermometer, and then the output is you have a heater, right? So if you put inside like an oven, you have one input, which is the temperature that you're reading, and you have one output. How much do you want to turn on that heater, right? And you can see in this image, it kind of demonstrates that. You have a feedback path. You have a controller, which figures out how much you want to turn the heater on, and inputs that into the system. And then, periodically or continuously, but in this case, everything can be discrete. It takes a reading from that and then feeds that reading back in the controller so it can make another decision about what it wants to do with the heating. So I first kind of got thinking about this when I started making yogurt. So this is my hack version of a yogurt incubator. And yogurt actually relies on bacterial strains called thermophiles. They're active between 40 and 43-ish degrees Celsius. And their peak is around 42-ish, something like that. So if you want to off Amazon, and I noticed that it has very fluctuating temperature, right? I can get it down to plus or minus, it goes within a degree Celsius, which is okay, but for certain applications that's not good enough. And yeah, by the way, you can save a ton of money if you eat a lot of yogurt by making it yourself. It's very simple. Don't waste all money buying it because it's extremely simple to make and better tasting. And then the next sort of thing that started made me start thinking about temperature control is 3D printing. I have a bunch of friends that were really into it and sort of got me into it too. Evian is one of them. She did a really neat talk about 3D printing a while ago. But yeah, so I bought a 3D printer a little while ago, and it's a really cheap one. It's the Monoprice Mini. And when I first got it, I noticed the temperature was fluctuating a lot too. It was going up and down and up and down. And I had some pretty bad prints, right? This one on the right is an example of a print where the temperature is a little bit messed up. And then I stopped that and then went to the other one and fixed it with a better temperature control. So yeah, 3D printing is another thing. You're going to need precise temperature control because you need to heat the plastic up to its melting point and then keep that at a stable melting point for it to adhere and all that. So my point is there's a ton of the applications of these. Not just temperature, although temperature is really important, right? Other examples of this are reflow ovens, when you make surface mount components. PCR thermocyclers, that's a biotech technology for cloning DNA. It requires getting the DNA just below its denaturing point and then bringing it back down again. And then all kinds of other things, not even related to temperature, right? Airflow, steering ships and planes. Actually, steering ships is one of the first original uses of a lot of this control technology. Robotics, biological processes, it's really, really, really key. So I'm just going to explain a little bit about one method of implementing a control technology, and then I'm going to show a little demo of something that I built. Just for some terminology, the first thing I'm going to talk about is a set point, right? So a set point is a desired value that you want, right? So suppose it's temperature, you want a specific temperature that you want it to be stable at. This is ideally the steady state of your system. So you would set a set point, and then the temperature or whatever would, as quickly as possible, go to that set point. And control is the thing that you can actually change, right? So in the oven example, you have a heating element, and sometimes you can just turn it on and off, like my really simple thermostat for my yogurt incubator. But sometimes you can actually choose a value, right? You can choose how many watts or whatever you want to send to the heater. And yeah, that's called the control. So one of the main principles of control is this concept called negative feedback. And it's kind of a fancy name, but it's a really simple concept, right? It's basically you're basically just compensating for any difference, right? So suppose you're at a set point, your temperature is at the temperature you want it to be, and the temperature goes up. Well, what do? You do the opposite of that. You reduce heat. You apply negative feedback. And similarly, if it goes down, you want to increase heat. So you're basically you're applying the negative, whatever you've observed happening, right? And it's in contrast to, for example, positive feedback, where that's the case where you have a microphone, you put it next to a speaker. In that case, you have building feedback. Every loop of the feedback continues to add and add and add. It's additive, and eventually you get that horrible squealing noise. But negative feedback is usually a dampening or better controlling mechanism. And then the next thing I want to just talk about is the error value. Error value is really simple, right? All it is the difference between your set point and what what it actually is, what you've measured, right? So like suppose you want you want a temperature of 40 degrees, right? You measured 20. Well, the error is 40 minus 20, 20, right? And yeah, that's all the error value is. It's just how far off you are at the set point. So a PID controller is one of many different ways to build a controller. It's really popular for a lot of reasons. One of them is it's very simple. It's really simple to implement, really simple to understand. And you can also make different combinations. Like you can just use the proportional and integral parts. And in that case, you have a PI controller. You can do a super simple one, just have a P controller, proportional. But yeah, anyway, I'll go into what those mean in a second. But yeah, basically that's what PID is. Those three words: proportional, integral, and derivative, and they're different components into the control. So first is proportional, and all that is just taking the error that you observed, how far off you are from the set point, and multiplying that with some constant called Kp, the proportional gain constant. And basically the idea is, to apply that direct negative feedback I was talking about, right? If you're 20 degrees off, then you're going to want to apply some proportional amount of energy to raise yourself up 20 degrees, right? It might be 500 watts, it might be 10 watts, whatever it is, like whatever you need to do, right? There's some constant factor, right? And similarly, if you're exactly at the set point, the proportional the error should be 0, and therefore there should be no proportional that you're going to apply, right? So it's just linear, constant multiplied by the error. And you can kind of think about this as accounting for the present error in the system, right? It's whatever the set point is that you've currently observed, how far off it is. That's what you're compensating for. The next is integral. And integral is basically the integral gain constant, which is another constant that you set, multiplied by all the previous gain errors that you've observed. So you take up all the errors that you observed in the past, add them all up, right? And some will cancel each other because some are over and above each other, like some are positive, some are negative. And that's what you do. And yeah, you take that big sum and you multiply it by the gain constant. And sort of the thinking for this is that if the error has been happening for a long time, like it's a really long-standing error, then you're going to want to try and correct it more, right? If it's a little blip that's only been happening for a little while, you're not going to correct it as strongly, right? That's the thinking behind the integral. And it's not always forever. It's not always the infinite past. Sometimes it's bounded, like the last 100 samples or something, right? But sometimes it is infinite as well, which happens to be easier to implement. Yeah, so so you can basically think about this as looking at the past, right? It's the component that looks into the past behavior of the system. Finally, we have derivative, and derivative is just the KD, the derivative gain constant, multiplied by the difference between the current error and the previous error, right? So if you are plotting the errors, it's kind of like the slope of the plot. And the thinking behind that is that if the error is increasing rapidly, then you want to correct it rapidly as well. And also, if the error is slowing down, the error rate is slowing down, you want to reduce the correction as well. And kind of the idea is like, yeah, like if you're getting close to the set point, you probably don't want to slow down a little bit. And this accounts for error in the future, right? So you have the past, the present, and the future. One of the issues with the derivative term is that often there'll be like some high frequency noise in the sample, and that can cause like big changes in the derivative, which throws a problem into your correction. Right? Sometimes that's fixed by filtering and so on. So yeah, putting it all together, once you've computed all three of those terms, then you just sum them together, and that's your control value. That's the value you feed back into the system. And there you go. That's the algorithm for a PID controller. Very simple. Well, a lot more simple than it could be. There's a lot more complex ones. But the real key is choosing those values, choosing the constants for P, I, and D, right? There are lots of ways to do that. There's some analytical ways where you're actually like busting out the calculus and stuff, and then there's simple like just trial and error experiments, and then there's a combination of the two. The thing is, there's no like right answer. There's no perfect constants. It's kind of a little bit of an art. because there's a whole bunch of different variously competing goals that you might want to optimize for, some of which I've enumerated here, right? Like one thing is when you change the set point, do you want it to skyrocket and go there as fast as possible? Like ideally that would be the case. However, sometimes like if you skyrocket and go there fast, it's going to like ring and try and like bounce around the set point. And that's called settling time, how long it takes to actually like, converge on the set point. Sometimes that's called ringing because it has a sort of sinusoidal shape, depending on the underlying model. And of course, in that case, it reminds you of like a ringing of a bell, right? That kind of noise. And sometimes you don't want to overshoot the set point. Like for example, some things like might burn if you go too high, so you don't want to actually like shoot way up. That might be a really important thing to minimize the overshoot. And sometimes there's more like subtle concerns like minimizing total energy expenditure. And then yeah, so in terms of 3D printer, they have this thing called G code, which is how you control it. And here's how you like change the PID values in your G code in your printer. You can just send this command. M301, H1. H1 refers to the heater. There's beds, extrude, and different. Some printers have multiple extruders. And then you just give it the PI and D values. And it just plugs it in, and then it applies that to the heating. So yeah, I wrote a little tiny simulation of the stuff, which I think is kind of neat. So yeah, it's I made this little simulation. And it's kind of like my oven example, sort of, right? So first of all, I'm just going to see down here in this little, maybe it's hard to see, but there's this little text entry box called current power. Right now that's set to 0. Oh, and by the way, the room temperature is considered to be 25 degrees exactly. So what I'm going to do is I'm going to advance time. I'm going to have 1 sample, 2 samples, 3 samples, oops, 3 samples. And you can see here that, up here we've got the sensor temperature, what the sensor is reading is 25 degrees. And you can see I'm applying 0 power all throughout this thing, right? And then, so now I'm going to go 1,000 points into the future. Boom, you can see like all throughout here, it's just staying steady. So it makes sense. We're not applying any power. And it's at room temperature. So I'm going to reset this. And now I'm going to give it, I don't know, like 50 power units, whatever they are, watts. It's not important for this simulation. And I'm going to go 10, oops, 10, 10, oops, why is it doing that? 10, and you can see it slowly rising up, right? In fact, let me go 1,000. There you go. So you can see that it's converging at whatever, 65 looks like, approximately. So yeah, it's slowly heating up, asymptotically approaching that, right? So yeah, now let's switch over. Oh, and then yeah, why don't I go back down to 0 power now and see what happens? So it's gonna start. See you can. It fell down to 0. The power fell down to 0 exactly, and then this thing is going to asymptotically go back to room temperature. And I made this slightly nonlinear in that it cools down faster than it heats up, which is probably opposite of a lot of ovens, but I think in like solder reflow, you sometimes need to cool down really fast. So it's not unheard of. Yeah, so that's basically the simple thing, right? So let's say we want to get it to 50 degrees, right? Well, we know it's something less than whatever I had earlier there, 50. So let's try 20. Too much. Oh, wait, that's 200. So it's a lot of trial and error to get that, right? However, so what I'm going to do now is I'm going to turn on the PID controller. My set point is at 50, and these are just some constants that I've chosen for the default. And then I'm going to go 100 in the future. And you can see after a little bit of futzing with the power here, it's converged on 50, right? So just so we can get a little bit better view of that, I'm going to reset it, get rid of all that history. And now the PID control's on, and it's at 50. So I'm going to hit 100. Oops, 100. And yeah, so you can see, it's not just like turning it on to the thing and letting it go. It's actually computing, every single value, a new power applied, right? And you can see as it's going up, it's slowing itself down. It's reducing the power until it gets, it's then here, like about, here it realizes it's shooting over 50. Oh, shoot, better bring that guy down. Gonna go 100 more in the future. And then, yeah, you can see it's kind of leveled itself off, right? But notice how there was this big overshoot, right? Sometimes that's acceptable, sometimes that's bad. So here, and the other thing I want to point out is that around in terms of like round off, it gets to exactly 50 and like, 180 here, right? It's exactly 50, right? Let's just reset it, turn off PID control, and notice that the stable state power was 31.25 units there. That's what the final power of the PID controller had it at to maintain that exact amount, right? So in that case, I'm just going to fast forward 1,000 here. Or no, let me go 100. So yeah, you can see it's slowly rising. It's still not even there, right? Yeah, so it's asymptotically approaching it. But yeah, look, we're at 400. I'll just go 1,000 ahead. So yeah, now to get to like the point where it's rounded off to exactly 50, we've got to go like even off this graph, right? So like whatever it is, here somewhere, 1,500, right? So it's like, I mean, as opposed to like about 200 units, it's like 1,500 time units for it to stabilize like that. Yeah, and then if you want, I have the website later and you can fool around with it, but I've got ways to introduce like Gaussian noise and another thing actually I want to show is that, so suppose I go back to PID control mode here, and I'm going to change the set point, change it to like 80, see what happens. Oh, look at that, it was able to correct itself. It jacked the power up. And yeah, another interesting thing, if I zoom in here, is that you can see that it actually sort of goes up and then down, right? And then here, it's up and it goes down below and up. It kind of oscillates back and forth towards it, right? You can make that more pronounced by changing these values, but I don't want to waste too much time. Oh yeah, and the other thing is that temperature spike. Suppose a temperature spike happens. Here, I spiked the temperature up to down to 30, right? So look what happened to the temperature. Temperature dropped, and then on the very next sample, the PID controller jacks the power right up. And then I'll go 1,000 for it in the future, and then you can see it corrects itself, right? So back to 80, which is the set point. So yeah, these particular parameters of the PID controller have a little bit of overshoot, but they stabilize very quickly. And yeah, there's some that have almost no overshoot, and there's some that have absolutely zero overshoot, and those are called critically convergent or something like that. But yeah, so I'll give the website for the simulator if you want to play around with it. It's kind of fun. I'm almost done here, guys. Sorry. There's if you notice that ringing that I was talking about, well, there's this one function called the sync function, sine of x over x, or t, sine of t over t in our case. And that happens to look a lot like that ringing we were observing. That's not a coincidence, but I don't have time to explain it right now. Yeah, it's if you're curious, look up the Fourier transform of a square wave, right? In our case, change suddenly a square wave. Yeah. Speaking of feedback, yeah. Yeah. So in our case, yeah, changing the set point suddenly to square wave signal. Look at the Fourier transform of that, and also look up impulse responses. And yeah, finally, dealing with noise, there's all kinds of ways to do that. Like I was talking about, you can take low pass filters of the signals that you have, right? Some of them are very simple. Like a moving average is also known as a finite impulse response filter, because it only looks at the most recent ones. And an infinite impulse response filter kind of takes into account potentially all of the past history, and it's just more easy to implement efficiently. And then you have filters that are called Kalman filters, which I might give a talk about at some point in the future, but they're extremely advanced and they can eliminate a lot of noise from sensor readings in a really impressive way. That's the end. Here's the links to the presentation and the simulation in case you want to fool around with it. And yeah, thank you very much.
Okay.
If there's any questions, I'll try and answer. Sure.
Please tell me you didn't do all of that for a lightning talk.
I wrote it all last night, but I was thinking about it for a while. Thanks.
All right.
Nice. Like if I never looked into that much detail, you thoroughly educated me in that topic.
Hi, my name is Satix. I'm one of the people working on Perl 6. And today I'm going to tell you what I think programming in the future is going to be like. Here's a small Perl 6 program that takes 32 random passwords, hashes them in a loop, and prints them out. This hashing function is slow on purpose, so it will be more difficult to crack these hashes. And this program takes 63 seconds to run on my computer. The processor in my home computer has 4 cores on it. If you have $3.5 grand, you can buy a processor with 14 cores. You can also use a Google Compute Engine virtual machine and get access to the 32 cores. And if you follow the news, you know that recently Princeton University designed a processor that they think they can scale to 200,000 cores. So even today, our computers have several cores on them, and it looks like in the future we will have more and more. But because of the way this program is written, it will only ever use a single core. But why do we program like this? We have all of this power at our fingertips, but we never use it. The main reason is just it's more difficult to write multi-threaded code. You have to write more code. The more code you have, the more bugs you have, the more time you spend programming, and the more expensive your software becomes. How many extra lines of code would we need to make our password hashing program multi-threaded? Some languages we would need a lot of lines. In others, just a few extra lines. But there's no language on the planet that would need fewer extra lines of code than Perl 6. And the reason for that is that we need 0 extra lines of code. We only need 2 extra words. Here's our hashing program, except now it's multi-threaded. We use the start keyword before the call to the hashing function to indicate that we want to run it in a separate thread. And at the end, we await all of those threads to finish the computation and give us the results. Now, this is a real program, and I ran it on several computers. A single-threaded program takes 63 seconds to run. The multi-threaded program that I ran on my home computer took 18 seconds to run. And when I ran it on a Google virtual machine with 32 cores, it took only 3.1 seconds. So by adding just 2 words of code, we made our program 2,000% faster.
And getting 32 cores.
So that's pretty amazing, but there's more. I mentioned that the more code you have, the more bugs you have, just because you have more places where you might make a typo or forget to do something. So we're going to make this program smaller by changing this for loop into a map method call. Now, this is a single-threaded program, but I can make it multi-threaded by adding a race method that will create a hypersequence and do this computation using all of your cores, wait for the results, and give them back to you. So that's pretty cool, but our program is still too big. We still have too many places for bugs to hide in. I'm not sure why it's displaying like that, but I'm going to scroll. Perl 6 has a hyperoperator. If you have a list of things, you can call a method on each of those things by prefixing it with a hyperoperator. So we can write our program that's all it. So we can write this program like this. We use the hashing function as a method, and we use the hyperoperator to call that method on each of the passwords. In fact, we don't need any variables at all, and we can just simplify it to this. So we condensed a single-line program into a single line of code. And we have all of these cores on our computer. But does this program use all of them? Is this a multi-threaded program with just one line of code? If you run it today, it will use just a single core, but the hyperoperator is designed to be auto-threaded, which means that the compiler will figure out for you the best number of threads to use to perform this computation. And this will be implemented sometime in 2018. And Perl 6 has a lot of cool stuff like this. We have promises, supplies, channels, junctions, feeds, All of this is part of the language itself, so you don't need to load any modules. So what do I think programming in the future is like? I think we're going to have more cores on our computer, and more people will use Perl 6 because it makes it very easy to use all of them. Check it out today at perl6.org.
And if you saw Damien's talk out here in August, he spent a lot of time explaining what Sofix just did in 5 minutes.
That's Damien for you.
Yeah. So let's see, who else do I have ready to go? Hey, Craig, I have your slides.
Sweet.
Why don't you come on up here?
Okay. Okay, so we've been talking a little bit about immutable data structures. I've been playing around with this database for a little while, and I figured not very many people know it unless you're in the Clojure community, and it is based around immutability, and it incorporates time into itself, which is pretty freaking awesome. And I think more people should actually be taking a look into what this is. So it's an EAVT store. So most people will just kind of be like, okay, well, what the hell does that mean? So basically, if you think about it, it's trying to take a relational database as tables, except they call them entities, and they're not the same thing as relations. You then can assign attributes into those entities. Those attributes can have values, and then I'm going to put this stuff at the bottom down here, but it also encodes transactions into the database itself, as opposed to everywhere else where you sort of have a transaction and magic stuff happens, and then when it's done, it's gone. It's actually in your data, and you can see what happened during anything that happened that you've actually done to your database. So immutability is key here. So this is kind of, as I was telling Dave a little bit earlier today, Datomic is a Rich Hickey joint. And if you sort of understand Rich Hickey's mind, he's wrapped immutability, and he's encoded time into how we write our programs. So if you think about your data structures, most people will actually just mutate data as it happens, which means that you've lost the ability to split that stuff out into multiple cores in a very meaningful way, unless you have, wicked structures for you that happen to be in your language, which is great. But, oh, damn it. Anyway. Inside of his database, what he's done is he's encoded time. So at any point when you happen to be running something, kind of like a transaction that happens to be in like MVVC, MVVC, you are looking at a point in time in your database, and you can go forward or backward from that point, however it is that you want, and you will only see what is happening and what is encoded at that exact point. Nothing has ever changed, nothing is ever lost. So what is this thing? Is it a key value store? No, it's not really a key value store. Is it a document store then? Because it seems to have all of the stuff that, say, like, I don't know, MongoDB has, but no, it's not a document store either. So is it a graph store? Because, it has, again, all of those things that the crazy graphs can do, but no, it's not. And the really ridiculous thing is it's all of those things at the same time, and it's kind of crazy. So it has a schema. So it's not a magical NoSQL, just throw crap in there and magically things will happen. And then later you're scratching your head because shit's missing and no one knows what's going on. So I've sort of tried to show what you can kind of have here. And basically what they've done is, say in the attributes, you kind of express them as symbols in Ruby or just kind of strings in other languages. And you can use this from other languages. You don't have to be in Datomic to do it. So you give it a name, you give it the type, and there are, I think, not a crazy number of types. It's most of the primitives that happen to be in other places. And then you can also, this is the really crazy part that I love, is you can give it a cardinality. You can say that any attribute can have only one of these things. Or if you notice from, say, community category, it can have a whole ton of them. So you no longer have this crazy thing where in a relational database, you kind of have these other sort of side tables and join tables and all of this other crazy stuff. All of your data is stored in this nice little succinct package the way that everybody wants to deal with it. So this is kind of what it looks like if you sort of just squint your eyes and look sideways. So they've serialized everything into a transactor, which means that anytime you want to mutate data, you're going to take that and it's serialized, it's a single thread. That's the only thing that can change the database. However, whenever you want to run a query, at least if you're running in the Perl version, or sorry, at least if you're running in the Clojure version, the client is the thing that's going to run the query. That's because of that is allowed because of the fact that time is in the database. So when you start your query, you check out whatever it is that you have at that point in time, and then you ask the backing store, which can be SQL, it can be like Dynamo, a regular SQL thing, or this magical InfiniSpan memory cluster, which sounds really freaking crazy, but I have no idea what it actually means. It's probably just like some dude in his basement that has a shit ton of RAM in his box and he stores all your data for him, and it's super great. Anyway, every single client that wants to run it can go and fetch the data that it wants because it's immutable, so nobody cares what it's there. It then processes what you want and gives it back to you. That sounds really cool. So it's all stored in SQL, right? That means we're allowed to use SQL? Well, not really. So you kind of have to learn this new language. It's not really new, it's kind of old. And this is the other kind of rich hickey joint, is all of the really wicked technology was sort of already built for us, and then everyone ignored it because they're like, well, we have all this really cool stuff, but all our machines are slow, so this sucks, right? Well, no, we sort of caught up to all of the really wicked ideas, and now they can make them work. So he went back and he grabbed Datalog, which is sort of prologue-y, and he made it work. And it's really crazy how you can look at things, and I can only really scratch the surface of it. So the first one is just a really simple query. And all it's saying is, from this thing called C, and we don't know what C is, but it's a binding. We're going to say, go into the database, and anywhere that C has an attribute called community name that is filled in, give me all of them. I don't care what the things are, just give me the data structures. The second one is saying almost the same thing, except that what it's saying is, I also want you to bind the actual value of the attribute to that n. So go in and find these things. Now, there's other ways in these queries. These are very simple queries. There are other ways that you can then go in and you can define what that n binding is so that you can only find community names that you're actually looking for, and it will only pull that data out for you. So TLDR is great talk. It's an immutable entity attribute value DB that is highly cacheable and has serialized updates. So why doesn't everybody use it? Because it sounds a hell of a lot better than just saying, today is Tuesday and tomorrow is Wednesday. But that, if you sort of just mutate your data, that means that today never really happened, but it did. So you don't need to go and think about audit trails. You don't need to go think about all of this other crazy logging structure. It's built in. It's really great. And you can use it from a lot of different places because they have this magical REST interface, which is super cool now. So yeah, that's it. You should go use it.
Where would you get hold of it?
Sorry?
Where would you get hold of it?
Datomic.com, if I remember correctly. So the one downside of it is a paid database. So you can go a very, very long way on the free version. And generally, their idea is by the time that you have to pay for it, you're making stacks upon stacks upon stacks of money. So it's cool to pay for stuff at that point. But yes, it's super great. And there's also a JavaScript version if you want crazy immutable data structures, but you sort of want a database. It sort of implemented this in JavaScript, and you can sort of send data back and forth between the two of them, and it's hyper crazy at that point, I guess. Cool.
Hi. Victor?
Yeah, it's on Keynote though. I think I can share. Boo. I need fancy graphics. Who do I email this to? I think I'm gonna try this keyboard.
Can you give me a?
I send you a link.
Sounds good.
I've never tried this before. Probably a new feature.
There we go.
No, it's talking.
There we go. Fingers crossed. Woo!
That's right. But it's very image happy, so it may take a while. All right. Just talking through together. I think it came out of a discussion with a coworker about some of the recurring challenges that we've seen, and somehow it's just turned into a talk. It's all memes. So just to give you guys a little bit of my history, kind of worked all over. Right now I'm at Flight Network, so we're like our core stuff's in Perl. John's from Flight Network. I think Derek's been around. A lot of this stuff applies to. Because I've been around for like the last, I think 6-7 years. I've just been doing consulting for ThoughtWorks, going all around the world, and I've never done a greenfield project. So I've always like picked up just messes, just like you see what developers have accumulated after a while, and you get like train wrecks after train wrecks after train wrecks, and you do kind of like, I find a lot of developers, you know, they do greenfield, and then when things get a little bit unstable, they peace out. So I have kind of developed a very particular set of skills, just kind of this forward thinking of like, you know, what do you do when, you know, somebody's going to have to maintain this developers, and I think the average span at a company for developers like something like 2 years. So you do have to keep that in mind, and most developers don't keep that in mind. So why do you keep missing deadlines? Horrible developers are horrible at making assumptions. They always underestimate. They don't take into account the maintenance stuff, the deployment stuff, and things just break. And yeah, even Dosakey's guy, I don't know what his name is, but the complexity is too damn high. Developers love to over-engineer things, reoccurring thread, just now following Agni, and then you should be bad about it. I mean, this is basic, I think, extreme programming 101. Greenfield project, I've seen, I think every single big bang, like I'm not saying obviously greenfield projects aren't bad, it's the greenfield big bang. I mean, I've never seen like a big scale, big bang rewrite work ever. Like, and I've seen like huge failures, like at really big companies. The only way I've ever seen it work is like piecemeal. Like, well, rip out the database, rip out Memcache, rip out this, rip out the front end, but not like, oh, let's throw everything out. It never works. Buzzwords. Oh yeah, developers love buzzwords. I know what's trending now.
Managers even more so.
Managers. Oh yeah, I've architects. Read an article on Hacker News, and then like, oh, let's do microservices because they're fun. Worst finding dev. Oh, object problem now. The whole throw it over the wall. I don't want to deal with it. But a lot of the stuff can be fixed. I mean, if developers take a more proactive stance on like making sure you're doing infrastructure as a service, or you know, proper integration tests, etc. Yes, please think of the maintenance costs long term. I know some good logging, maybe use Splunk, etc., but don't just like hack it in and like, oh, I'm not going to worry about it. We need to go deeper into, you know, what else is causing these problems. Why are you writing so much code? Just keep it simple. I know you guys, you were talking about lines of code. I think I hate code metrics in general. I find like a code coverage, every code metric for me is bad, except for like lines of code. I mean, if I could write something in 10 lines of code versus 100, I mean, and not cheating with like semicolon and everything one line. I mean, logical lines of code, yeah, by all means. I mean, we all think we're smart. I can only fit so many things in my head, and just keep it simple. Replace the silly. Every time you don't follow Yagni, God kills a kitten. Follow Yagni. This is actually Yagni. I think I'm going to post this at work, John, because like this is my number one thing for Yagni. Like,
What's the
does everyone know what Yagni is?
No.
Oh, you ain't gonna need it. If you're, it's or Occam's razor. I think that's another one that I've. There's two solutions: complicated solution and a simple solution, and you can't prove either one. Like, there's no argument for like, oh yeah, we definitely need this one. Then just pick the simple solution. Don't say, oh yeah, we might need in the future this scalability maybe. Just pick the simple solution. I mean, if you're being agile and lean over time, you can make improvements, but don't overcomplicate things. Premature optimization, that's talent. Yeah, I know we do have a lot of cores nowadays, but I mean, I'm not gonna, and if it is lean and like it's not a lot of extra code, by all means do it. It's where I think I've seen a lot of problems where people are like, oh yeah, I need to optimize, maybe do some inline assembly, all this crazy stuff. But it was never a performance issue. So like, why are you complicating the code? Scalability, if you keep using that word and I don't think you know what it means. people always kind of, I find people forget what's important in terms of scalability. Like usually you have a front-end application. I mean, often it's your database. I mean, you really got to figure out what you want to scale. You need metrics. Your software is too difficult to maintain because you try too hard to optimize it, but that's not my business. Yeah, I've seen lots of unnecessary optimization and just stop it. I don't think this really means so much. Like, just I saw this picture and like it's a reoccurring theme. Like I think I've done a lot of this throughout my jobs. Yeah, I mean, anytime I hear words I don't understand, like not like talking business value, like talk to me or like business or whoever in terms of business value. Like I want to hear like, oh, if only we had monads and so forth. Like what value is this going to give? I don't want to hear about async checks on a token and run of optimistic something. Just give me the simple solution. If you need to expand it, like, oh, monads are going to give us performance. That's great. I heard you like abstractions. Here's another library, or here's another library to add more abstractions to more abstractions. Like
Now you're talking about Node.
I got some rants on them. Yes, layers upon layers upon layers of abstraction. I guess it kind of came out of the whole Java mindset from 15 years ago. You got to like create abstract factory, single adapter methods, and if you just write the code in Python or Perl or Groovy, I mean, you just do it in a couple lines of code. So you're telling me less is more? Yeah, absolutely. Oh yes, this one.
Yes.
Shiny new technology. Tell me exactly where the business value is. I mean, I'm all for like, I mean, we can't all be programming Fortran on Cobalt. I'm all for like using newer technologies, but don't just, oh, extra technology of the day, let's use that. And waste, oh yeah, say microservices again. Gary, I've worked on a lot of microservice projects. I think actually Fred George has done some awesome videos. He's an ex-developer as well. Some awesome videos on microservices. If you guys want to like really see how it's supposed to be done right, usually you don't need them. I've done a lot of microservice work. I mean, if you don't, I think Martin Fowler did a good article on you have to be this tall to like use microservices. And I would say that most people aren't this tall, or at least most companies aren't this tall. You really need like proper testing, proper CI, proper DevOps. Most companies aren't this tall. And I know that it's exactly what you're saying. I see it a lot from managers nowadays. Like, oh, if you only use microservices, everything could just be auto-deployed and like on demand, and it's just going to make things easier. No, like there's so many costs that you have to factor in, and nobody sees them. There's no like core functional people in here, right? Haskell or. I love function. I do find that function like the. I mean, every language nowadays has some form of functional programming. I mean, even Java, although it's kind of ugly. I do find it makes things more readable in general, except you start going really hardcore where you're kind of doing it for the sake of doing it. Like, oh, I'm going to be like pure, everything's going to be immutable and and you don't factor in like it's a trade-off. I've seen things be completely abused. And it's just for the sake of theoretical code purity of like, oh yeah, this is going to be 100% functional. Yeah, so if you could keep things simple, that'd be great. This is the other question I always like to push out to developers is, like, are you really adding value, or does it matter? Like, does it really matter that like you're gold plating this little thing? Is it golden hair? Is it just me? I think this is the only meme that I could find on gold that kind of looks. Actually, and this guy just got. I think apparently this guy just got assassinated a couple months ago. I did this talk in India when I was there 2 days after he got shot. But Einstein, what's the ROI? I also think of the ROI, like what's the return on investment? I mean, there's always work. Any shop you go to, there's always dev work, but where are you getting the most value? Automate all the things. I would actually scratch it out to like most of the things. People also spend too much time on automating things. Which one's the deploy button? People say that they automate things until you kind of ask them to walk through the steps and like, oh yeah, log into this, SSH into here, deploy this into Artifactory. Make sure you pull this down from NPM and then click this in Amazon. No, it should be like I run one command, deploy dev. And if my I don't know, my AWS key is set up correctly, it should just work. Yeah, and imagine a world with easy one-click deploys. I'm big into like DevOps. I need everything automated and easier to maintain code, increased developer velocity. Yes, and the spend. A lot of node hate here.
Just, yes. I don't hate Node. I just hate how it handles dependencies.
No, you hate Node.
Okay, I hate Node.
I think I hate how people use it.
Well, when watching the Webpack on one of our apps install, it's just.
I agree though, because monads, mo problems. Definitely.
I hear these words and like, just give me value. I'm not like, I know I love cool tech. I'm not against cool tech, but just don't stop doing things for the sake of doing it. Like if you want to do open source and play around with cool little like closure or whatever, like I love programming languages, but people think that like, actually the other thread that I see is like, you just use this programming language, all your problems are going to go away. No, that's never happened. You know, like ThoughtWorks is always about like pushing the envelope. I know, like, who remembers Ruby on Rails? I was like, and down.
We're a Ruby shop.
So that's okay. Ruby or Ruby on Rails? Yes.
And also no at the same time.
Yes. And we do know, but we're doubling down on Perl. I don't think I know Perl gets a little bit of.
It's not sexy.
I know it's sexy.
Well, to give you a little background into our situation, we have I hate to say this term, but an organically grown Perl database that's about, what, 10 years old now, 12 years old now, something like that. And there had been a push to sort of phase that out and replace it with something more modern. And then it got realized just the level of effort required to do a complete rewrite of 10 years of business logic that had gone into this massive code base. And you know, there was a push towards that rewrite happening, but it, you know, the bright and shiny wonder tools did not end up living up to their expectations, and you know, we started writing, you know, things like little endpoints that exposed some of the functionality of what was previously viewed as a black box monolith, and people went, "Oh, hey, you can do that." And we started being able to deploy stuff out of the classic code base a lot faster than people thought we could. And we're continuing to do that now. So
yeah, so that's absolutely like that. Because this deck actually wasn't like talking about playing it out with this deck.
Sure.
No, I mean, I've seen.
But if you know the internal story of the past while of development at our company, this deck becomes much more relevant.
But it is like the big bang thing. I've never seen it work. I was reading about, there's a classic Joel Spolsky post on the worst mistake a company could ever make is rewrite the software from scratch. And I think he references Netscape 5, and then like everyone like who still uses Netscape Navigator. But I've never seen it work, and it's kind of exactly what John was saying. You look at it, oh yeah, I could replace this, but you don't realize, I mean, that's 10 years of development. Oh, sure, we'll just replace it. No, there's like 10 years of little nuances and interfaces, you're not going to replace it, the only way to do it right, I mean, you can't just like leave it alone and like keep adding pieces.
About 6 months ago, I took one of our particularly hairy chunks of code and I basically just flowcharted it, and I pulled in two of our business team, our very senior business team members to look at the flowchart, and I said, okay, we're going to go through this, and you're going to tell me if this is appropriate. And the complexity level on it was like through the roof. It's really untestable stuff. But we went through it, and the looks on their faces as they were going, okay, so it does that hasn't been right for 5 years. I thought we got rid of that. It does that. Yeah, and you know, we managed to clean up a lot of stuff doing that. But the idea of taking that and completely rewriting it from scratch, when even just fixing what's broken is a major undertaking. And I don't know. It's hard to judge what the worst case is in terms of resource usage, but
there was a company in Toronto that was a competitor for Ticketmaster, and their whole back end was Perl. Well, front end too. And a former coworker of mine was brought on and said, "You're going to maintain the Perl version while we do the Java complete rewrite from the ground up."
well, I've heard this story.
5 years later, the Java version that was supposed to launch after a year had not launched, and he transitioned to a Java developer because he wanted to keep his job. They went out of business 6 months later.
How do you tell the difference between Yagni and oops, didn't think that through?
I think it's experience, because you're right, I can't like, I'm more experienced, I do have to start investing long term. I would do stuff preemptively, like from day one, set up CI/CD, even though it's not giving me business value. From day one, set up static code analysis, even though it's not really giving me value initially. Is there a clear-cut rule? No, but I would say most developers, 99% of the time, they're on the wrong side. It's like, I don't even worry about it. And most of the time, if you're, I hate using the word agile because I think it's been overused as well. But if you are like being transparent and like you know where the project's tracking, and maybe you have, if you're if performance is a concern, you have the metrics, you can try to be preemptive about it and then start investing time into it when it's needed. But in general, I tell developers not to worry about it.
There's a historical precedent, I guess, that with the development of Unix, that back then everything was encrypted and or encoded in order to be very tight and lean. Well, they just started writing things on in text files and keeping it simple because they hadn't got the resources to do anything else. And it turned out that it all worked fast enough anyway, so there was no need to go into the complications.
I don't think I've ever had to deal with like hardcore performance optimizations. Like, I'm not saying like start using quicksort. I mean, you're implementing your own quicksort method. I mean, just use the library. But I don't think I've ever had, like, unless you're doing like hardcore, I don't know, video encoding or game programming. I've never seen a case where I've had to like really start optimizing. And then yeah, maybe web traffic where you got, okay, maybe memcache this and maybe a database and make sure you put the index on it. But in general, especially on the CPU side, I don't think I've ever been, I know it kind of goes, I still love parallel programming, but on the CPU side, I've never needed to really worry about that. I'm not saying, I'm just saying for business.
I think one of the fun too with dependencies and the things you build up with adding library and library what happened in the Node ecosystem earlier this year. If any of you heard about it, there's a nice little module in on NPM that was left pad. It was literally to pad strings with spaces on the left. Well, the author in a fit of pique removed it from NPM and brought down half of the Node ecosystem. No one could install anything anymore.
Actually, let's say the one thing I would have added, if we were talking about Node, the one thing I would have added here is avoiding premature modularization. I kid you guys not, I may have been working on a recent code base recently where a 4-page application got split into a 4-page application that needed no back end. Somehow got split into 14 source code repositories and 14 NPM modules. And some of them were just like 10 lines of, like once you stripped it out, and I think we stripped it out.
Strip all the packaging out.
Packaging and like they include this and like the golf balls, and like, it was literally like kind of what you were demonstrating, which is like here's the value, but we used some other language, but yeah, premature modularization. I don't know. I think it's this. I don't know. Do you guys do that?
I think so. Not especially.
Monolithic. Actually, another thing. I didn't really talk about. Monolithic has like such a bad name. That's it. Like monolithic apps versus like segregated. I don't know where that came from, but like I'm all for just keep it together, but still well encapsulated, and then start ripping it out. But you don't need like every. I think there was even an article I read on Deloitte of all places, where there's a guy recommending that anything, that every service shouldn't have more than 100 lines of functionality. Which makes no sense to me. I'm like, why? The amount of overhead.
Microservices.
Yeah.
Those are nanos, maybe picos.
Any other questions? Cool, thanks guys.
Thank you. I'm not sure. Do we have any other speakers? Richard.
Mine's quick and dirty.
Oh, and Jim still had something.
Yes, I will be ready whenever.
Okay. You want to close this out then, Jim?
Pardon me?
Did you want to close this out this evening, Jim? Did you want to be our last little anecdote?
Yes.
I can go whenever.
Okay.
All right, cool. So this will be pretty short, sweet, just some tips and tricks from SSH. Probably a lot of you might know them, but maybe there's something hopefully in here that you might find interesting. So first thing, SOX proxy, very useful feature that you can do. Allows you to securely proxy your traffic through another machine using only SSH, so pretty useful for hotel and airport Wi-Fi. I was recently actually in Singapore and in Hong Kong, and I basically used this completely exclusively to proxy everything back to my home server here in Toronto. Also helpful for Netflix, so I can still watch versions of things while I was.
Are you serious? You've got to be the only person in history who went back
I
to
know.
get Canadian Netflix.
I know. But yeah, but it does help for that. One quick note though, Netflix though does have a listing now of different services. So even trying to proxy through, I think my Dream host or that I have, what is it? One of my VPS that I have in New York, and they actually blacklist that. They can detect that. So they're getting smarter at this now. But if you have your own like little server and it's not publicly known that it's a proxy, it should work pretty well. And also, of course, any other time you don't want your immediate network infrastructure to sniff your traffic. You know, maybe you're at work and you want to do some personal things that you don't want your IT administrators to know about.
Funny you should mention that, because they just did that today. Put a malware blocker.
One, also make sure though that your browser is using SOX 5, not SOX 4, because SOX 4 will leak DNS lookups. So it'll still go through the non-proxy to do DNS lookups. So make sure that most modern browsers now, I think they're pretty much SOX 5 compliant, but just something to watch out for. And yeah, it's very simple to do. Just SSH to whatever host you want to proxy through. You set up, you give it the -D flag, give it a port number. This will just open up on the local host, the proxy at that port, and then you just change your browser or whatever thing you're using to go through the tunnel through that port. The -N is just there so that you don't actually run a command just opening it up at the top. Another useful thing too is port forwarding. So make remote services appear as though they're running on the local machine that you're SSHing from. Often services only are binding to the loopback interface anyways. So like MySQL or maybe VNC, which is good for security because you don't necessarily want these services to be world accessible. But then it's nice that you can actually just SSH in and use that as kind of both the secure tunnel in terms of being encrypted and the fact that they're not listening external port. So yeah, secure, useful for VNC, MySQL, and basically anything else you can think of. I remember one time we had to exfiltrate logs from customers that we were doing some performance testing on their box, and we had to get basically a hot fire hose of logs off of their box, and this was the only way we had to do it. We had 5 separate SSH tunnel connections going to get these logs off. And yeah, basic syntax, you just give the -L option. The first port is the port that you want it to be on the local machine that it will list on. And then on the other side, you can pick, it's not just the local host, you can pick anything that's on the network that's accessible from there. So in theory, you could also use this as proxy to create kind of like a bounce through and go to another box and so on. So you could create a string of these if you really wanted to like go around the world and be like a hacker type. And then the target port. Another really cool thing, and I just learned about this relatively recently, and it is a relatively recent addition, is authorized keys command. So everyone knows about the authorized keys file, where you put your public keys for the user when they log in, so that the SSH server can verify that they have the correct private key. But you can actually now, instead of just having a static file, you can actually dynamically generate it. So you now give it a command, let's say a Perl script or curl or whatever, and basically it can do whatever you want. It returns basically, it prints the standard out at the authorized keys format. So basically you can now do your own kind of custom authentication without having to do anything with PAM. So like a really simple use case, for instance, would be, let's say, you have a distributed system, all these different hosts, and you just want to have one area where you as the administrator can set up public keys for the users. You just put it up on a web server somewhere, make sure it's obviously secure with SSL, maybe pin the cert ideally, and then you can have it so all of these hosts, wherever they are in the world, they just hit the script that just checks, it just scrapes the site, gets the authorized keys, and that way you can easily revoke, change those keys in one spot. And easy control of distributed logins. And of course, it can be much more complicated and do whatever the heck you want. So basically, authorized keys command, you put this in your SSH server configuration, you just give it the path to the script, and you also have to give it a user that it will run that script as. And the interesting thing too, it passes the username as the parameter in the RDB to the script. So you can use that to do further stuff. In this particular case, this example is just a really simple example, just scrape some web page somewhere, and it's assuming that already has the correct format, the SSH RSA and everything like that. So that's kind of a nifty, relatively new feature that's been added, I think, since, I can't remember, I think it's been there for a couple of years. Another useful one is force command. So this is useful, only works if the person's using public key to sign in, but you should always be using public keys. So basically, don't give your user a shell. Give them a command instead to run. It's pretty useful for automated accounts if they only have like a limited thing to do, or as well if you want to only have an SFTP only server. So in this example here, you would set it up so, okay, Bob's your uncle, the user. When he logs in, he'll be routed to the /media directory. No X11 forwarding, no TCP forwarding, and you will force command here as the internal SFTP server. So basically, this forces it so that this person cannot log in. They can log in as an SFTP user, but they can't actually get a shell. And they're also rooted, so even if they did, they would be stuck within that particular subdirectory. Another one you could do is securely store your SSH keys on a GPG smart card. So I have right here, this little thing here, it's got a smart card in there. So I have my SSH private key in there. And so I don't actually have to store it on my disk. I can store it in here, and it never leaves here when I do the authentication. So basically, the crypto operations are done on the smart card. Your private key never leaves it. Another thing, just aside, you should use ideally the -O flag if you're generating private public keys in the future. Basically, this forces OpenSSH to have a new format and the old format. The old format is like compliant with 10, 15 years, and the new one actually uses password salting and basically ACS to basically prove the brute force attack strength. Because right now, if your private key file gets compromised, it's actually really easy to run a brute force attack against it. Because usually there's no hardening that's been done. So that's another thing that if you're security conscious going forward, you should do. And also if you're using ED 25519 keys, they are automatically like this. Although they have their own problems because SSH agent doesn't seem to work. So, anyways. So some configuration to get your GPG working. You basically just have to, the way this works is you kind of have the GPG agent running. It's just a little, server that runs. And basically your SSH, it basically replaces your SSH agent. And so your SSH server connects to it, and it is the one that then handles the communication with your smart card that's plugged into your local machine. And so at this point, you basically just set this up in your bash RC, and this will just export the correct socket, PID, and so on. And if the server's not started, it'll just start the GPG agent there. And then in your GPG agent, you also just have to tell it that I want to enable SSH support. And at that point, when you do your login, it will actually come up and ask you for your PIN to your smart card, enter that, and then it just works. And it's pretty cool. And yeah, any questions?
So with the GPG agent, can you still do forwarding like you can with the SSH agent so that you can sort of use your gateway as like a bridge point?
Yes. So yeah, you just use the -A flag, and you can. So I do this like I go from my laptop to my home machine, forwarding from this, and then from there I go to one of my servers that I have out in the net.
So does that do the same thing where it sends, like it forwards the actual private key off of the smart card, or does it do some sort of?
Well, the private key is never actually sent. I don't believe it's just that it's cached. The ability to do it is cached here, but it's never actually sent off. Cool.
Do you have your key backed up?
No.
Oh God.
That's okay.
What if you break it?
Then I can still get in other ways. Well,
We can just go home, right?
Yes, like, so you can always get the console, right? The web console.
What do you think about those? When you generate a key and it shows the little picture of
Yeah,
things?
sure.
Yeah. What do you think about that versus fingerprints? Is that actually better in any way, or because you can make fuzzy fingerprints that look like 80% of the way there, and
Yeah,
you could probably make these things look the same too.
I've never really paid that much attention to the ASCII art ones. If I generally will just check the fingerprint, like, because the other thing too is, yeah, even with the fingerprint, you can in theory make fingerprint look probably half decent. And lots of people just check the first few characters and the last few characters.
THC has a utility to do it. You can, if you spend a couple days of crunching, you can get like the first 20 numbers and the last 4 numbers or something. And
Yeah, I generally just check the actual fingerprint. It's really the only way. I mean, if somebody's gonna, I guess most attacks they probably wouldn't be that sophisticated, but if somebody is man in the middle of you, then it could be that they're pretty sophisticated. So I want to check everything. Cool. All right, thank you.
Thank you. All right, so now I think we will go to some closing words. Jim, you're up.
Okay. First of all, with a few seconds of HTOP, which I introduced, even as Doug was speaking about it earlier, so you can see how it looks. Okay, that's enough of that.
Still get mistaken for you.
close enough.
So I emailed Doug in the list earlier today that I had a lightning anecdote. In late August, I was in California on a job interview, one of the ones where I did not get the job, as I referred to earlier. But after that interview, I spent a day at the house of the fellow who was my best friend in high school, but whom I only see about once a decade since the 1980s. The decade in which we were in high school was considerably earlier than the 1980s. In the 1980s, he got married and I met his wife, but I've seen her even less, approximately 3 or 4 times over a 35-year period. And I believe the last time that I saw his wife in person was around 1998, which would have been before I was doing Perl. And I know that the last time I saw my friend was in 2004, which was before I was ever employed doing Perl. So a lot of water under the bridge. They live in West Los Angeles near Santa Monica. He is an art historian. She is actually a high-level curator at the Getty Museum, which some of you may have heard of because the oil multi-billionaire J. Paul Getty left a fortune to this set of museums and institutes, and they built this colossal campus sitting atop one of the most valuable pieces of real estate in Los Angeles. And I had a chance to tour the Getty Museum and its institutes the following day. But in any case, so we were driving along some street in Los Angeles in heavy traffic, of course. And my friend's wife, her name is Gail, she was asking me about what I do because, you know, she had last met me when I was a social worker in the New York State psychiatric system. And I said, well, I'm a programmer and I'm here for a job interview, and I mainly work in this language called Perl. And Gail immediately said, oh, Perl, we use that all the time. And of course, you could have heard the sound of my jaw dropping because she would be about the last person I would expect to know the name of any particular computer program or programming language. I mean, I would expect her to know Excel and Microsoft Word and so forth, but I wouldn't have expected her to know the name of a particular programming language. So I started to speak with her about that, and she said, yes, we use, she said she doesn't program in Perl herself, but she knows of it, and she supervises several people who extensively work in Perl. And she said, in particular, we use it for the German sales project. And I said, well, what is the German sales project? And she said, well, you know, between 1933 and 1945, the Nazis in Germany confiscated vast amounts of art mostly from Jews and from other people whom they were exploiting or exterminating or conquering. And they just ravaged all these private collections and museums throughout Europe and brought it back to Germany. And a lot of this, it's not like they just stored it under in a vault somewhere. It entered the market. It entered auction markets in Germany. And there are records of these auctions. And the records of these auctions are what people have used in the last 2 decades in order to try to get restitution of the art to the pre-Nazi owners of the art. And of course, I had read about this, you know, in newspaper and magazine articles. So I was familiar with this thing, but I never knew that there was any sort of Perl connection to it. Well, she said, yes, it's actually a multi-stage process. And what I want you to do is tomorrow when you come over to the Getty Museum, I want you to meet with the 2 people who are actually involved in this project and who, you know, who write the software and who manage the databases, et cetera, et cetera. And the following day, when my friend Bill and I went over to tour the museums, we also spent some time meeting with Kelly, one of the 2 women whom my friend Gail supervises, who's involved in this. And she gave me this explanation of how they use Perl as in one stage of the cleanup document, because of course, if you're looking at auction catalogs from the 1930s, what you are looking at is manuscripts that have been fed into computer programs and analyzed with OCD readers, and they need to be corrected. And then all that data needs to be translated into some sort of standardized format so that scholars can look at them. The standardized format being CSV. Why CSV? Because scholars are used to dealing with Excel, right? So the people working at the Getty Museum use Perl and particularly Perl's capacities like spreadsheet read Excel, spreadsheet write Excel to as a vital step in the preparation of databases that scholars will subsequently use to study the history of German art auctions during the Nazi period and as a step toward restitution. And we were in the process of writing up a sort of a Q&A interview post that will go to, among other places, blogs.perl.org, in which they discuss their use of Perl in this process. And I'm just going to now show you the name of the website that one of the websites that they use there. Let me go to screen share. Let me go to, let's see. I guess I go here and I go to here. Is that showing up? German sales catalog? I'm not sure if I have the sequence of.
No, not yet.
Okay.
Clicking
Where
the
did I
screen
just
share
lose
button
my?
in the upper left.
Let me see. Screen share.
Then ask if it wants full screen or this app or that app or what have you.
Yeah, screen share. Is that showing up?
Nope.
Okay. Well, I don't.
Fire
What
it
I'll
onto the
do-
list, and I'll put it onto Meetup and the mailing list as well.
Yeah. Here, I'll put it in the. There it goes into the group chat for this. But in any case, I thought this was very, very, very interesting because, you know, everyone who's spoken tonight, generally, if you're using Perl or if you're using any of the other technologies, you're using it in a very commercial, for-profit context. And of course, that's where I worked for 10 years. But it's always interesting to hear about where your technology, in particular Perl, is used, where it's, you know, it's not driving your web advertising performance or whatever, where it's being used someplace, broadly speaking, in the nonprofit or educational sector. And you know, I'm sure you're familiar with the site blogs.perl.org. I expect to have something up on the German sales project and Perl's role in it within the next 4 weeks, and look for it there. Thank you.
Cool, thanks, Jim.
Built-in Perl might be interested in that too.
Yes.
Was that the Getty Museum modelled on a villa in Herculaneum?
Quite possibly, or at least, well, I think what you may be referring to is the previous version of the Getty Museum, which was built out of one of J. Paul Getty's estates in Malibu. That, which was an immense place, and I think it certainly looks like the Roman villa, that was the old Getty Museum. The new Getty Museum sits on a hill in Brentwood, along with 3 other art institutes, each of which is called Getty something or other, but which is actually an independent institution. And you know, they've got like Carrara marble, Travertine marble. It sits on a hillside. You have to park in an underground garage and take a tram up to the top. They have money to burn.
Well, great. Thank you very much, Jim. And thank you to all of our speakers, remote and otherwise. Have a good evening, everyone. Thank you very much. Cheers, everyone.